Okay, this is the last part of the statistics unit, 7J, standard deviation. Standard deviation is the most widely used measure of spread of a sample. Okay, that is because a lot of real-world data comes out in kind of a normal shape, where the most popular values are kind of right in the middle and then it curves out. And this bell shape works really well with standard deviation, so that's why we use it the most in the real world. Here's the definition. Standard deviation measures the deviation between scores and the mean. Okay, the larger the standard deviation, the more widely spread the data is, and vice versa. It's better than quartiles because it considers all the scores, not just 4 of the scores. Okay, so the most common way to do it is with ungrouped data. Maybe this is somebody's IB score, okay, 1 to 7. Okay, and I might want to find the standard deviation. So in order to do that, here's my formula. It says take every score, subtract from it the average, square it, and then divide by the number of scores. So first we need the average. So if we were to find the average, we would do 2 plus 4 plus 5 plus 5, add them all up, right? And that equals 35. And divide by the number of scores, which is 1, 2, 3, 4, 5, 6, 7. 35 divided by 7 is 5. So the average is 5. Okay. Now we're going to subtract. So let's just erase all of this. I'm going to take all the scores and subtract from it the average. And I did the average as orange. Okay. So subtract from it the average. So 2 minus 5, negative 3. That means that this score is 3 below the average. 4 minus 5, negative 1. If we would do them all, five minus 5 is 0, 0, positive 1, and 2. Okay? If we were to add up all of the numbers in this column right here, they would add up to 0. So adding them up won't give us a measure of how far every number is. So what statisticians do is they square it. So negative 3 squared is 9. Negative 1 squared is 1. Okay, we go ahead and do all of these. And this gets rid of the negatives and the positive. So if you add up all of these numbers, you would get 16. 16 is measuring how far all of the scores are from the average. So looking at my formula, okay, we now have this part. The sum of the differences squared. And so our formula says to take that number and divide it by n. And we said n was, again, 1, 2, 3, 4, 5, 6, 7. And if you do that, it is approximately 1.5136. So basically that means typically students in this class scored plus or minus 1.51 from 5. So anywhere from 5 minus 1.5 to 5 plus. Okay, that would be, on average, the students in this class earned 3.5 to 6.5 on their IB score, which would be amazing, okay? Almost passing to really great score, okay? We can also do this with grouped data, okay? And all they've done to add to the formula is little f. They times everything by the frequency. Before I show you that example, let me read this. Note, a large population of many thousands or even millions has a mean, which we denote mu, and a standard deviation called sigma. Often mu and sigma are unknown and too difficult or too expensive to find. Therefore, when we take a sample of sufficient size, its mean is x bar and its standard deviation is s. If we believe that the sample is a true reflection of the whole population, then we use x as an estimate of mu and s as an estimate of sigma. We will talk about this in class, but for our class, so IB doesn't want you to get confused, we'll always use sigma or sigma of x, and we'll talk about that in class. All right, let's go back to the group discrete data. So here are a list of scores. Maybe these are ACT scores, not great ones because nobody got over 20. But instead of listing the number 11 3 times, they said it's just happened 3 times. So we could list it out and do what we did here, but that would suck, okay, because we would have to have 50 columns. Instead, we're just going to follow along. So what they do is they take every score and times it by the frequency, right? Because basically we have 11, 11, 11, 12 4 times, and if we times it, we're saying this is 11 3 times, we have 33 points. 12 4 times, we have 48 points. Add them all up, and this is the sum or the total of all the scores. So before you find standard deviation, you have to have mean. So they take the mean and divide it by the number of scores and get 15.62. Now we're going to use this mean to take every score and minus the average. Okay, so we're going to take, notice we have 11 minus the average, so 11 minus 15.62, and that is where they got this number. Okay, 12 minus 15.62, and that is where they got these numbers. And then again, if we were to add this up, it'd go to 0. Okay, so we can't add these up, so we square it. So they squared. Negative 4.62 is 21.344. And then this is how many, this is the difference squared that 11 is from 15.62, but 11 happened 3 times. So we have to times 11, this one by 3. This one happened 4 times, so we times it by 4. This one happened 5 times, so we times it by 5. And it's basically going to add up all the differences. Okay, so that's what this little f does, is it's timesing it. So now we put this number in our standard deviation formula, divide by 50, and we get a standard deviation of 2.38. Often we will do this in the calculator, but I have to show you how to do it by hand in case you need to do it on your IA. Okay. The last thing is grouped continuous data, and it's exactly the same, but remember, if they don't give us the raw data, they tell us there's one score in here between 0 and 9. Okay, 1. It could be 0, it could be 9, but I don't know, so we pretend it's the midpoint, 4.5. I don't know what the score was in here, so we pretend it's 14.5. I don't know what the 2 scores were between 20 and 29, so I pretend it's 24.5. Again, to get the middle, you just do 20, you do the endpoints, add them up, and divide by 2, and that'll give you the middle. Okay. Once you have that, we can ignore this and do exactly what we did here. So we're saying, we're pretending that 4.5 showed up once, that this showed up once, that this showed up twice. Okay. Add them all up. This is my total. Total divided by 80 scores, and we have an average of 59.75. And then again, we take each score. In this case, our estimate score 4.5. So this one came from 4.5 minus our average of 59.75, and we'd get negative 55.25. Do that for all the scores. And then again, we square them to get rid of the negatives. And we can't just add them up yet because this one only happened once, this one only happened once, but this one happened twice. So notice there was 1 times this, so it stayed the same. This showed up once, but this one right here happened twice. Okay, and so we did this times 2. So they times them all by their frequency, multiplied them all by their frequency, added them up, and the total of the squared differences is 22,594. Stick that in our formula, divide by 80, and we have a standard deviation of 16.8. Right now, you should be able to do this by hand in a table. You may not understand what it means, although you're going to see this video after the lecture, so you might, but we will keep practicing. Lastly, I just want to talk about variance. Variance is just the square of the standard deviation. So if we go right here, variance would be this part. 22594.99 divided by 80, which is approximately, okay, so the variance is just approximately 280, I think that's a 9, maybe it's a 4, let me double check. Oh, it should be 282.44. Okay, and it's just another measure of spread. Like we quoted 16.8 for standard deviation, some statisticians will use this. Okay? All right, let's compare the spread. Calculate the coefficient of variance. And you know what, we're not going to do this. They've taken us out of the core. So we just need to look at these double box plots. Okay? An office worker has the choice of traveling to work by car or bus and has collected data giving the travel times from recent journeys using both of these types of transportation. He is interested to know which type of transportation is the quickest to get him to work and which is the most reliable. So he went ahead and put this in list 1 and got his 5-number summary and a box plot, and put it in list 2, okay, and got his 5-number summary and a box plot, okay, and let's just double check. This one's car, just highlight this stuff, and this one's bus. Okay, and he's using this to decide the method of transportation that's quickest and most reliable. Okay, so if we look at the middle, the median 50% of the time, bus travel takes 18 minutes or less. Okay, that's at 18. If we look at the car, it's 22 minutes or less, i.e., bus travel is generally quicker. Okay. Not only that, it's more compact, so it's more accurate. While in your car, there are some days it may take you, okay, one of those days it took him 43 minutes to get to work, and here he hit all the green lights, and it took him 13 minutes to get to work. So not only is the middle generally lower, but this one is more reliable. Okay, and so that's what they're talking about here. They found the range in the IQR. Here the range is 30. For the bus it's 14, so this one, there's definitely a greater spread for the car, okay, as well as the IQR 10 to 4. So if I was him, even though car would seem to be faster, and sometimes it is, 25% of the time it is, it's less reliable, and you may hit a bad day and it takes you 3/4 of an hour to get to work. On the bus, you can read your paper, and you're going to get to work most likely between 16 and 24 minutes with a couple of outliers. And even these outliers are lower than the highest time in car travel. So whenever we compare, we always want to look at shape, center, spread, and outliers. Okay, so the shape, they're both kind of symmetric. It's not that important here. The centers were definitely lower, and the one spread was lower. And then, yes, this one had outliers, but actually that's in its favor, because even its outliers, it has a couple of outliers, were lower than almost like 25% of the car data. So in this case, it is much more reliable and quicker to take, not a car, but a bus. This cannot be in Utah, because Utah buses are not that reliable and they run like every hour.